Well, I want to thank Jason and the College of the Canyons for the opportunity to present this morning. My topic that I will be discussing relates to equitable and sustainable affordable housing, and it's my hope that some of the items discussed would be of help to some of you. The effects of the global pandemic that gripped the world in 2020 are still being felt today. The pandemic has changed the landscape of common day living, affecting the provision of essential household supplies to the way we communicate and perform our work and studies. Amidst this changing world landscape, a crisis has surfaced and become more pronounced, affecting the life and well-being of many, that is housing affordability. With the United States experiencing a record high inflation, the state of California has battled the crisis for housing affordability for decades. In its effort to mitigate the impact of overburdening living expenses, often reflected in higher rent and mortgage payments, the state of California has adopted a method of addressing housing affordability through the form of community development. Quoting from Gian Haynes Green's book, Asset Building and Community Development, I quote, "Community development can be understood as a planned effort to build assets that increase the capacity of residents to improve their quality of life. These assets may include several forms of communal capital: physical, human, social, financial, environmental, political, and cultural," end quote. Many of these planned efforts for community revitalization has often been focused on blighted and struggling communities. These communities often face difficult challenges that range from having access to healthy food options, mitigating exposure to various forms of environmental pollution, to blighted neighborhoods affected by adverse land use and planning. As the housing crisis worsens, city and state officials have recognized that addressing housing affordability in California often means addressing the equitable and sustainable development of these affordable housing projects. The two cannot be severed. Furthermore, successful community development is often a result of creative partnerships between city officials, developers, and designers, undergirded by the input of local community voices. These partnerships are essential not only in the effort of mitigating the housing crisis, but also in implementing an equitable and sustainable design practice that improves the overall health of underserved communities. During my tenure in one Los Angeles-based architectural firm, YM Architects, I have personally witnessed the ample challenges and opportunities in our design practice focused on designing affordable housing projects throughout the state of California. Some of the projects that we have undertaken in our practice have been particularly exacting, as we have had to address difficult project sites that beckon a resilient design approach. These project sites have been affected by adverse conditions in the form of exposure to environmental pollution hazards, contaminated soils or brownfield sites, and adverse land use and planning. I will be sharing some of these projects with you this morning, along with some of the environmental challenges that were needed to be overcome for the success of each of these projects. The first project I will be sharing is known as El Segundo Family Apartments and 127th Street Apartments. These two projects were built simultaneously side by side and would share a single lot of about 2.5 acres. Completed in 2018, the projects provide a combined total of 160 new low-income special needs housing designated for Mental Health Services Act and California Department of Health Services, homeless and chronically ill homeless veterans and their families. The projects would enjoy close proximity to a wide variety of amenities, including access to public transit, permitting ease of transportation for local residents, along with access to local retail stores and other vital services to serve the resident population. Residents would also enjoy a wide variety of amenities that would provide for communal gathering and social learning opportunities, all crucial to support the well-being of its residents. These amenities include a wide variety of spaces, such as communal clubhouse for social gathering, educational classrooms, technology centers that would provide for training resources, and a large communal kitchen that would also be available to residents for cooking classes and other gathering opportunities that would facilitate for communal dining. In addition, the design and construction of the project would adhere to green building principles intended to enhance the well-being of the project's residents and overall performance of the two projects. Through the incorporation of a low-impact development approach, the natural processes of soil infiltration and stormwater filtration system intended to protect water quality would be retained despite the redevelopment of the site. This was achieved through the use of pervious paver courtyards with filtration planters that would clean, treat, and recycle water used on the site. A solar water thermal system would also be utilized in the project as a means of incorporating a readily available renewable energy system that would permit water heating through the energy harnessed by the sun. The system would permit for compliance with local code requirements targeting energy compliance while providing for a more energy and cost-efficient system. These two projects, however, had the very difficult site directly adjacent to one of the busiest freeways in the greater Los Angeles area and frontage to other major vehicular thoroughfares. The challenges of building two affordable housing projects within a 500 feet distance to the freeway were phenomenal. Exposure to adverse environmental air quality impact and severe noise levels were needed to be overcome for the success of the project. In employing design strategies to minimizing the air quality impacts of the project proximity to the freeway, the following design features were incorporated into the design as a means to mitigate these impacts. The first strategy executed was an implementation of an efficient building system to be used in the project. The heating, ventilation, and air conditioning system design would inevitably play a significant role in addressing any air quality concerns that needed to be mitigated. Through the use of an efficient air filtration system incorporated into the mechanical units, and the air circulated within the units would significantly be improved to that of the exposed air outside the building envelope. This was achieved through the use of filters meeting or exceeding the ASHRAE standards 52.2 minimum efficiency reporting value, or MERV value of 11. The minimum efficiency reporting values of our cleaners or filters are based on 3 combined average PSE points established through tests performed at the manufacturer's specified airflow rate. With higher MERV value, the better. Ongoing maintenance of the air filters and mechanical systems would be of utmost importance in order to maintain an acceptable standard of indoor air quality over the lifespan of the project. The introduction of fresh air intake would also be of the essence and needed to be carefully introduced into the project in order not to compromise air quality within the building envelope. This was achieved through the use of house ventilation and fresh air intakes located on the roof. All fresh air intake would go through the process of thorough air filtration before entering any occupied spaces. The second design strategy employed in the effort to mitigating adverse impacts caused by the proximity of the freeway was in a careful placement of the building footprint. By maximizing the distance between the building and the freeway source, we were able to create a physical buffer between the building structure and the freeway. Also, by utilizing creative landscape techniques, our landscape design team was able to screen the freeway frontages with landscaping features that would remove particulate matter. Along with these strategies, the careful arrangement of all entrances and exits, outdoor courtyards, and any envelope fenestration were essential in further mitigating any further adverse exposure. The design would minimize the amount of operable windows along the freeway facing frontages. This would substantially limit any potential exposure to any particulate entering the units without filtration, while also limiting any exposure to severe noise levels, as we will see in a moment. Outdoor courtyards made accessible to residents, permitting for outdoor recreation and use, such as barbecue grills, children's play area, and community gardens and seating, were completely screened from the freeway by being located in a central courtyard. The four-story structure would act as a physical barrier that limit visibility to the freeway and would also reduce sound to residents utilizing these outdoor spaces. Residential projects fronting a major or secondary highway also experience more severe noise levels than other projects. Increased noise levels are further experienced by residential projects within 500 feet of a freeway. Careful design consideration for ambient noise levels brought on by the project's exposure due to mobile noise sources were also of the essence in the effort to secure the well-being of the future residents. In the endeavor to mitigate the increased noise levels, the design employed a series of design strategies that would significantly reduce exposure to higher than normal noise as experienced by residents. The first action was to specify all exterior windows having a line of sight of a major or secondary highway to be constructed with double pane glass, since fenestration is the weakest point in a wall assembly due to the inability to insulate the opening. Double pane windows would compensate for the absence of deafening insulation. Further, the use of exterior wall construction assemblies, which provides a sound transmission coefficient value of 50, was provided as part of the construction of the structure. These efforts were the means of sound insulation sufficient to mitigate interior noise levels below a 45 dBA in any habitable room, which would be a significant reduction to what would otherwise be experienced had these measures not been employed. Further environmental impacts from higher ambient noise levels due to being located in close proximity to a freeway would moreover be required to be analyzed and sufficiently addressed. The design strategy specifically used to mitigate this concern was in the form of addressing the actual site of the project and building construction specifications. The construction of a sound wall within a few feet from the freeway and along the border of the entire site facing the freeway created a sound barrier that would mitigate the direct sound triggered by mobile noise sources. By screening the freeway frontages with landscape vegetation, both high and low frequencies would also be significantly abated. Once again, the fenestration of the building envelope facing the freeway would need to be intentionally treated. The exterior windows were selected to provide a minimum sound transmission class of 30. A higher window sound transmission class allowed for the reduction of interior noise levels to be within acceptable thresholds of livability for residents whose units were facing the freeway. As you can see, a successful design in a complicated site often means utilizing creative and rigorous design solutions for the project to thrive. This could not be more evident than in the next project I will be sharing, known as Carson Arts Colony. This project is located in the city of Carson, an urban setting located about 13 miles south of downtown Los Angeles. The project was completed in 2019 and provides for a 46 units affordable housing community made up of a series of structures servicing a community colony of artists and their families. Residents of the project enjoy a series of amenities unique to serve resident artists. A gallery for accessible and affordable exhibition space for the local nonprofit Universal Voice, along with sound-rated music rooms with pianos permitting the free use for resident musicians to practice. and a wood shop with machinery space and equipment, along with small studio space, are all available for artists' use. A key supporter of the project was the city of Carson, who envisioned this project's success as a catalyst for further revitalization of the city at large. During subsurface investigation, however, the site was identified with a series of subsoil conditions that needed to be remediated due to the site's previous use. The site, consisting of 2 parcels of land, approximately 1.8 acres, and located on the west side of South Main Street within a mixed industrial and residential area, housed a single-story building constructed in 1969 prior to the development of Carson Arts. A limousine bus repair shop, used for over 55 years, and an auto wrecking and salvage yards operations were located at the site. As a result, the site was evaluated during the subsurface investigation for the potential impact of petroleum hydrocarbons and volatile organic carbons present at the soil, along with other soil gases that could have been released during the operations of the auto wrecking yard. The presence of hazardous materials, wastes, and petroleum products were carefully analyzed. A 375-gallon capacity above-ground storage tank utilized to store waste oil was also identified. In addition, subsurface investigations determined the presence of an abandoned septic system and dry well. During soil remediation procedures, the project hired a soil mitigation team of experts that provided recommendations to how best to treat and mitigate the identified soil contaminants. The soil management measures identify guidelines to be followed during grading and soil disturbance activities. Identifying affected soil was crucial to remediation, as contaminants were only identified in specific areas that had previously been exposed. Handling potentially affected soil during excavation meant that the construction team would be isolating the contaminants by placing the affected soil on plastic sheathing to stockpile. Once the soil piles were secured and monitored in accordance with South Coast Air Quality Management District rules, the team had to make sure no contaminant found its way back to the site. The final step of soil remediation employed the disposal of contaminated soils through the export of soils to an outside soil disposal facility that had been certified and approved by the rigorous California environmental standards. Once the soil remediation had been completed and subsurface conditions presented a clean site, the design was able to proceed and green standards were utilized to further promote the project's success. The projects employed a series of design strategies that would achieve a Green Point rating. Project meeting this rating provide a credible way of certifying that the project has made sustainable environmental standards for efficient, durable, healthier homes. Similar to a LEED rating, the Green Point rating offers a series of categories that the project's design compliance represents successful attainment for green standards. Carson Arts achieved a series of points affecting the design and implementation of all aspects of the project, from its site, building envelope, and building systems. The project's large and narrow site offered ample opportunities for sustainable best practices. An opportunity presented due to the size of the site included the establishing of a stormwater control performance path. This credit would permit the reduction of the quantity of stormwater leaving the site while improving the quality of the stormwater runoff. The project landscape design also played a major role in the overall design of the project. The use of hydrozoning, plants grouped together by water needs, was especially useful, as the project also employed a community garden, fruit trees, and other vegetation that require varying degrees of watering. Through the use of an efficient landscape design, the utilization of appropriate plant selection and location was established at the site in order to secure to reduce the propagation of invasive species while reducing water needs. By minimizing turf in the landscape and providing a dedicated meter for landscape irrigation, the project ensured an efficient use of available landscape opportunities. The selection and specification of strategic building materials were also incorporated into the green design of the project. One of the materials used in the main structure of the building was engineered lumber. This permitted the incorporation of smaller diameter rapid growth lumber assembled as engineered materials to be used. Durable and non-combustible cladding materials were also specified in the overall design of the exterior building facade that permitted an attractive and modern appeal to the project. Fiber cement panels and metal wall panels were integrated along with plaster cement products that would promote a durable material while increasing safety through the use of non-combustible materials. Building thermal resistance through insulation that would meet CDPH standards method, limiting volatile organic compound content and emissions, and the use of dual pane windows permitted for a tight and energy efficient building envelope. Building systems were also employed in the effort of achieving a high standard of green design, such as installing water-efficient fixtures and a high-efficient water heating system that relied on solar thermal to heat the gas boiler. The last and final project I will be sharing today is known as Washington 722 Transportation-Oriented Development. This infill project, located in South Los Angeles, provided the revitalization of an underused urban area. Infill construction refers to the building or reuse of existing structures within underutilized areas that are part of an existing urban fabric. The project was designed as a mixed-use transit-centric project adjacent to San Pedro Street Metro Blue Line station, facilitating the use of local public transportation as a means to access the site. As a 55-unit affordable housing development for low-income family and seniors with special needs, the project provides a wide variety of amenities designed to enhance the well-being of its residents. Some of the amenities include access to a computer room and a graphic media center, fitness center, and a community room. In addition, ample bicycle storage was provided as a means to ease mobility for residents. The project also provides access to residents to grow their own vegetables at the neighboring lot serviced through the South LA Community Farm. Incorporating the surrounding historic South Central neighborhood was essential to the project. This was achieved by representing two local community voices in the form of prominent murals featuring workers' rights activist Rigoberto Jimenez Oropesa and food justice activist Ron Findley. These murals were created over one of the project's prominent facade in the effort to maximize visibility. One of the unique features of the project was that in order to accommodate the density of the project, an existing structure was rehabilitated and a new structure was constructed attached to the existing structure to create a cohesive building. The project included the complete demolition of 3 commercial structures and the interior demolition and reconfiguration of a 4-story building. Under the review of the project for conformance with standards under Section 106 of the National Historic Preservation Act, the subject property was not eligible for listing on the National Register of Historic Places. However, adjacent properties located near the project site's area of potential effect were deemed eligible for listing, and careful consideration was needed to be taken to secure their well-being. The reconfiguration of the existing structure to be used as part of the project would require it to be compliant with the interior standards for rehabilitation and the California Historical Building Code. Due to the project's frontage of a major thoroughfare, elevated noise levels were identified and attenuation would be required to mitigate the effects of increased noise levels. After a noise study was conducted per the U.S. Department of Housing and Urban Development guidelines, noise levels of the proposed site were calculated to be at 73.82 dB by 2023. As a result, higher sound transmission coefficient ratings of windows and walls were needed to be achieved in order to improve the project's exposure due to the elevated noise levels. In addition, other design recommendations were provided as a means for sound attenuation design features, elevating the residential component of the project above the podium and minimizing exterior windows having a line of sight of any major thoroughfares would permit for acceptable levels of interior noise at habitable spaces. Providing an interior courtyard would also permit for outdoor recreation opportunities available to residents while mitigating the effects of excessive sound to residents using these outdoor amenities. The project design and construction achieved LEED Gold certification. As many of you may be familiar, LEED certification, developed and administered by the U.S. Green Building Council, provides the framework for green building design supporting equitable communities. As part of LEED certification, the project attained several points in its site and building design features. Certified under the LEED for Homes Mid-Rise Multifamily category, we investigated a series of design strategies that would meet and exceed the LEED requirements. This was a crucial aspect of the design as an infill project. As such, the project had immediate access to all the essential services necessary for the project. The project's close proximity to a major transit line and other forms of public transportation also provided the necessary framework for being considered a community resource. The project also provided ample opportunities for access to open space by providing a landscape courtyard with a series of amenities for residents. Through the use of non-invasive planting and drought-tolerant planting, the project was able to employ landscape design and irrigation that were carefully carried out. A principal concern for energy compliance was reducing the local heat island effect. This was particularly crucial as the project is located within close proximity to downtown Los Angeles. Through the use of light-colored exterior building materials, landscaping, and a rooftop courtyard, we were able to achieve a project sensitive to the heat island effect while providing ample recreational opportunities to residents. Building materials and systems that relied on active energy systems were also carefully selected to optimize energy efficiency compliance, water use, and indoor air quality. Finally, to conclude, indoor air environmental quality was of high importance due to the location of the project next to a major vehicular thoroughfare and required careful consideration of the heating, ventilation, and air conditioning system to mitigate adverse exposure to potential air contaminants. MERV 11 filters were also utilized in the project as part of the air filtration system. Noise exposure was also mitigated through the use of exterior wall construction and assemblies, providing a sound transmission coefficient value of 50. And with that, I wrap things up. Thank you so much for your attention.